In this video, we're going to cover risk and capital budgeting. We will start with the risk portion. A quick refresher of probability distributions. There are many distributions: uniform distributions, Poisson distribution, log normal distribution, etc., etc., etc. We are going to be using normal distribution and the calculations for it, which is a typical practice in finance. So just remember that you may have a set of observations, which when you plot them in a frequency type chart or histogram, it may look like this, and that's considered discrete because each value is in a specific place and is an either or. But then this could also be represented, depending on the situation, with a set of calculations in a continuous distribution, where it's pretty much anywhere in the area under the curve. So it's not fixed, it's just anywhere in an area. So it's pretty much infinite possibilities and probabilities. In this specific example, notice that in a normal distribution, as always, in this case, they have a 0%. Could be, let's say, a stock return, for example, could be anything that is 0% is right there in the average in the middle. And then as you move left and right to higher percentages or lower percentages, even negative, then notice the probability becomes lower and lower as you move away from the average, which is in the middle. And that is your continuous distribution view. Okay, so when we are dealing with normal distribution and continuous distribution, in order to talk about risk and the probability of something happening, negative or positive, one thing you always want to look at is at the expected return, the expected value, which is another way to say average. Now, what happens is that if you have a situation where every possible outcome has the same chance of happening, then you just can do a regular average. But if you have a series of events with a different probability of it happening, like chances of rain versus not, or economy doing really well versus doing normal versus doing recession, then there could be different probabilities of each one of those. So when you have that approach, you cannot do a regular average, you have to do a weighted average. And that's where this formula comes in play, where you see the probability times the outcome, and then you add it together. And it gives you an average, just weight it to the probability. We will work on this formula and calculations on the Excel video associated with this material. Then once you have that expected value, you can use it to calculate the variance. This X bar here, that represents the value we calculated here. They don't show it as X bar, but X bar means the same as that here. And that is your variance calculation, which also has a probability element included. And then the standard deviation, which is a square root of the variance. And again, the Excel video, we will put these in practice. So if we were to show you why this is useful or how it can be interpreted, let's say you have two different projects and you got a blue line. One follows the blue line on the probability distribution, and one follows the red line on the probability distribution. Now, notice that both have the same average right there in the middle, 10%. They both have a 10% average on the expected return, expected value, whatever it is that you want to call it. However, they don't have the same dispersion or the same standard deviation in this case. Notice that the one in the blue line gives you 10%, but the most you might lose is a negative 20%. While the red line averages 10%, but you can lose up to about 35%. So the red line will be considered higher risk, because for the same expected return of 10%, you have a chance of higher losses. versus the blue line has a lower chance of losses, or the most you will lose, there will be like negative 20%. Many ways to see it, but that's why the blue one is considered lower risk and the red one higher risk. Now, one thing to always understand is the risk-return relationship in finance. So the blue line has lower risk on the losing side, but also has lower potential on the extra gain side. So the red line shows you that could go all the way up to 55%. There's a chance, small, but there is. However, the common wisdom is that if the average return is the same, you shouldn't be taking the higher risk, because you're still going to average out to the same. So taking the higher risk for the same return, it's not efficient. And that's where coefficient of variation also comes in play. And we'll explain that better on the Excel sheet, because I'll show you that how much risk are you taking for every percentage of return. Now, when we talk about uncertainty and analyzing, we have different ways to approach it. We have sensitivity analysis, we have scenario analysis, there's Monte Carlo simulation, and there's many more. We're going to cover first the sensitivity analysis, and then in a separate video, we'll talk about the scenario analysis. And these will be on the Excel videos. Just to talk a little bit about sensitivity analysis. In sensitivity analysis, what you do is you have different points where values are inputted in order to get, let's say, the NPV. So then what happens is that with sensitivity analysis, you can then change one at a time to see how it impacts the end result. Scenario analysis, which we'll discuss later, does a different approach with changing multiple inputs at the time. But we will start with sensitivity analysis, which in a nutshell is change one variable and see how the outcome, the end result changes, and you hold everything else constant. We will cover this on the Excel videos. And for now, we'll stop the video here.